Hey sis, before we jump headfirst into C Sharp, let's take a quick detour into the world of binary numbers. Don't worry, it's not as scary as it sounds. Just think of binary as your computer's native language. Just like you need to understand a language to communicate effectively, understanding binary will help you communicate with your computer and write better code. So, what is binary? Binary is a number system that uses only two digits, 0 and 1. That's it. It might seem limited, but it's the foundation of everything your computer does. Every piece of data, whether it's a picture, a song, or a piece of code, is ultimately represented as a series of zeros and ones. So, why does binary matter for coding? You may be wondering, why do I need to learn about binary if I'm just going to be writing code in C Sharp? Well, understanding binary is like peeking behind the curtain to see how your code actually works. It gives you a deeper understanding of how computers store and process information. This knowledge can help you write more efficient code. When you understand how data is represented in binary, you can make better decisions about how to store and manipulate it in your programs. It also helps you debug more effectively because if you encounter strange errors in your code, understanding binary can help you pinpoint the underlying issue. It also helps you just appreciate the elegance of computer science. Binary is a simple yet powerful system that underlies all digital technology. Learning about it can actually deepen your appreciation for the field and make you a more well rounded programmer. So, how binary works, think of it as just a simple analogy. We can think of binary like a set of light switches. Each switch can either be on, which is represented by a 1, or it can be off, which is represented by a 0. By combining multiple switches, you can represent different numbers. In this example, the top row is all zeros, which indicate that all switches are off. This represents a very specific number. In the middle row, all switches are on, which represents a completely different number than that in the first row. And finally, the third row is represented by a sequence of switches that are on, off, and on. This again represents a completely different number than the first two rows. In our conversion chart, you can see how decimal numbers can be represented in binary by a series of zeros and ones. To represent 0, notice that all switches are off. So we have 0, 0, 0, 0, or off, 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 off. Whereas to represent a 1, the decimal number 1 in binary, we would represent it with the switches off, 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 and then on. Off, off, on, off is another sequence of switches, and it represents 2 in decimals, 2 in decimal, and so on. So each digit in a binary number, 0 or 1, is called a bit. With just 8 bits, also known as a byte, B-Y-T-E, you could represent up to 256 different values. That's every number from 0 to 255. That's enough to represent all the characters on your keyboard and then some. So let's break down the conversion of the decimal number 296 into binary. We'd start by dividing the 296 by 2. It's an even number, so we'd get 148 with a remainder of 0. When we're converting from decimal to binary, both the result, or the quotient, and the remainder are important. Notice the format we're using to complete the division. We keep the remainder on the end, and then we continue dividing out our quotient. Eventually, we get down to the smallest possible number and we end up with a final quotient and a final remainder. So now, if we take the list of remainders and reverse the order, we get 296 converted to its binary form, which is 100101000. Each remainder, the 0 or the 1, represents a digit in the binary number. The rightmost digit corresponds to 2 to the 0th place, or 2 to the 0th power, the units place. The next digit, 2 to the power of 1, then 2 to the power of 2, and so on. So 100 actually means 1 times 2 to the 8th power plus 0 times 2 to the 7th power plus 0 times 2 to the 6th power plus 1 times 2 to the 5th power plus 0 times 2 to the 4th power plus 1 times 2 to the 3rd power plus 0 times 2 to the 2nd power plus 0 times 2 to the 1st power plus 0 times 2 to the 0th power. And if we add all of these numbers up, we get 296. So there you have it, sis. You now unlock the secrets of binary code, the language of computers. While it may seem like a different world at first, understanding how to convert between a decimal and binary is a fundamental skill for any coder. Think of it as adding another language to your coding repertoire. With practice, you'll be fluent in no time, and this knowledge will serve as a strong foundation for your future coding adventures.